Hi, hello. Welcome back to our YouTube channel. By the way, for those who haven't subscribed yet to our channel, please click subscribe and click on the bell icon so that you'll be updated to our newly uploaded videos. Okay, so this time we will discuss unsymmetrical parabolic curve. Most students have had a problem with this because of the tons of formulas they're required to memorize. But what I am going to present in this topic is basic. Just like I hope you have seen the previous video for the symmetrical parabolic curve. What we did there, we just used the basic formulas without the need of, that's our target, that's our main mission here, no? To use the basic concepts only. We don't have to memorize long formulas. Okay, so ito na, no? So we will know the elements of the curve using the basic principle only. So unsymmetrical, how is this different to a symmetrical parabolic curve? Okay, let's have a practical problem. A negative 4% grade at station 5 plus 700 and elevation 110.2 is to connect to a positive 6% grade. So this is a dip curve from a negative to a positive, or sag curve, in other words. So the other grade is at station 6 plus 100 and elevation 105.2. So determine the elevation and grade of the point of common curve, PCC, and also the location of the, specifically the elevation, and also the stationing of the point of vertical intersection, or PVI, or normally we call it PI. Okay, right? So let's plot the given grades. So first we are given the initial, the PBC, the beginning of vertical curve. Okay, the grade is negative 4%. The stationing is 5 plus 700 meters. And then the elevation is 110.2. All right, that's given. Now the other end, the EVC, the end of vertical curve, or sometimes we call it the PC. This is the PC, by the way, and the other one is the PT. Okay, so that is positive 6% grade. Okay, and then the elevation is 105.2. The stationing is 6 plus 100. Okay, so this is the given grade. So we will connect this with a vertical parabolic curve. Okay, so the total length of the curve, the horizontal distance, and this is also the length of the curve, is 6,100 minus 5,700. That is 400 meters. And the vertical difference in elevation between A and B ay 110.2 minus 105.2, that is 5 meters. All right, we will check if this can be connected with a symmetrical curve. We do not know yet, actually. We do not know yet if this will require only symmetrical or asymmetrical. Well, you will know because if this length, the center, if this intersection is exactly at L/2, then this can be connected with a symmetrical single parabola. But if this will not be located at the middle, then that should be a compound or an unsymmetrical. Two symmetrical parabolic curves. Dalawa. Okay. So let's solve for these distances. Let's call this this is a PVI, no? The point of vertical intersection of the grades. All right. So let's get these distances. Let's call this L1 and this as L2. Of course, L2 is 400 minus L1. How will you get that? How will you solve for that? Formula. Okay, there is a formula for this, but no need to think, don't need to memorize that. Just basic only. Very basic. Okay, so let's get these vertical offsets, vertical distances. This one first. Take note, this length or the grade of this is 4%. This is the length, L1. Okay, and we know that the grade or the slope is rise over run. So if you want to compute this vertical drop, that will be equal to the product of the slope and the run. 0.04 times L1, this distance or this height here. Did you get this? Slope is rise over run. So rise is equal to slope times run. All right, slope times run. And also on this side, this vertical drop here is 6% times this distance, L2. Okay? Well, obviously, from the figure shown, if you subtract this or this height equals this height plus 5 meters. So 0.04 L1 is equal to 0.06 L2 plus 5 meters. Okay, is that obvious? That's so clear. You don't need to memorize formula for that. All right, then substitute L2 being equal to 400 minus L1. It will become like that. So there's only one unknown there. Then we can solve L1. 290 meters. And L2, of course, is 110. 400 minus 290 is 110. Okay. Notice here, the PVI is not at L over 2. Meaning this cannot be a single parabola. This is not symmetrical. This requires two parabolas, two different parabolas. So that is why this is called unsymmetrical parabolic curve. All right, but before we do that, let's solve first the PVI, the PI, the intersection. We cannot solve that. For the elevation, that will be elevation 110.2 minus this drop. All right, so the elevation of PVI is 110.2 minus the drop is 0.04 times L1. We already have the value of L1. So the elevation is 98.6, okay? 98.6, and the stationing is 5 plus 700 plus 290, L1 is 290, so that is 5 plus 990 meters, okay? So we already did the first question, okay? The second, the location of PVI, the stationing, and the elevation. Now, the PCC, the point of common curve. What is that? Where is that? Okay. So ito yun. This is now our parabola, parabolic curve. Okay? The point directly above or below, in this case above because this is a sag curve. If this were a semi curve, that will be below. That is your PCC. That's the point of common curve. Okay. Just like the same as PCC with our compound curve in horizontal curves. So, but this is a point of common curve. Okay, so to locate that one, and of course this is the car. Okay, now this has a slope. That is not a zero slope. Take note, it is not the summit. It is not the lowest point yet. Well, that cannot be. Well, maybe, but you cannot generalize. So let's say there is a slope there. Okay, so let's say it's going down. It can be going up or going down. Okay, later on you will know when it is going up or going down. You can after this I will explain that to you. How will you know if it is going down or going up? I'm talking of this. Let's call it G3. The grade of that common tangent is G3. Okay, now take note that this is now a single parabola, this side here. Another parabola. So the two parabolas have a common ends here. All right, so one parabola at the left, another parabola to the right of PCC. Okay. So this is a symmetrical parabola and another symmetrical parabola. So if this is a parabola, so the property of parabola, which I discussed in my previous video, the symmetrical parabolic curve, the tangent of a parabola, because this is the same parabola. This is a different parabola, take note. Okay? So the tangent of a parabola always meet. The tangents drawn to a parabola is always halfway, meeting halfway. So if this is L1 here, this should be L1 over 2 and L1 over 2. Just like on the other side, if this is L2, 400 minus L1, this should be L2 over 2 and this is L2 over 2. Did you get that? Okay, so that's it. Then, our mission here is to solve for this common tangent, G3. How will you solve that? Okay. Notice here the tangent, I highlighted it. I used a bold line. Okay, have you noticed that? This red here, this green here, and this green or the blue here. Okay, to emphasize that, let's highlight that area. Okay, the red, this is 4% unknown slope, and this is 6%. This is the vertical offset, the vertical difference of A and B, 5 meters. Okay, so this is L1 over 2 and L2 over 2. Now, if you add this one, L1 over 2 plus L2 over 2, that will become L1 plus L2 over 2 if you add this lengths. So L1 plus L2 obviously is 400. So in other words, this distance from here to here is actually half of L. In this case, that's 200 meters. That's always the case. That's always the case because L1, if you add these two, it will become L1 plus L2 divided by 2. And L1 plus L2 is the L. Ibig sabihin, this is half of the length of the curve. Okay, so I hope you understand that. Now, how will you solve for G3? Okay, this is how we do it. You will use the elevations. Okay, look here. The elevation here is 110.2. Okay, 110.2, that's it. Then let's go down to this point. Okay, the vertical drop here is 0.04 times L1 over 2. By the way, L1 over 2 is 145. So we will subtract the vertical drop. Look here, 0.04 times L1 over 2. Did you get this? So this is now representing this point. And then, okay, again, we do not know yet if this is going down or going up. Let us generalize that. Let's assume it's going up. Okay, although it looks like going down, but never mind, it doesn't matter. Let's say, okay, let's say going up. So we will add the vertical rise of that. That will be G3 times L over 2. So we will use plus sign. G3 times 200. This is it. The distance, the horizontal distance here is 200. Did you get this? So you are now at this point. Okay? And then we will now add. Okay, obviously, this is going up. Plus 6% times L2 over 2. Plus 0.06, L2 over 2 is 55. Half of 110, 55. Okay, and that is elevation 105 point. Did you get what we just did? We started with this elevation minus this height plus this height minus this height here. Okay, sorry, this height minus this height plus the vertical here plus the vertical rise here equals the elevation 105 point. I just assume this is going up. I hope you were not confused. Okay, I should have used their negative, but anyway, just to make it because we do not know yet if this is going down or going up. Okay, only one unknown is present here. We can solve G3. G3 is negative. Look, negative, meaning it's not going up, it is going down. But this is still correct. Had we used negative here, then we could have get here a positive answer. That means that your assumption is correct. Here, it means it is going down. Negative 1.25%. All right, that's the key to the solution here. If you get that grade there, then everything becomes easy now because this is now a compound, the two parabolic curves. Okay, so let's erase this shade here. Now let's draw now the grade diagram. We can now draw the grade diagram, just like what I did with the previous video. If you haven't watched the previous symmetrical parabolic curve, I suggest you watch it so that you will have an idea on what we are doing here. Okay, this is now the grade diagram. Okay, the grade at A is negative 4%, negative 0.04. The grade at PCC is G3, which we have just computed, negative also, 0.0125. That one. And the grade at B is 6%, 0.06. So this is as a parabola and another parabola. There are two parabolas here. So for this parabola, the grade diagram will connect these points. And for the other parabola, the grade diagram will connect this point. So this is the grade diagram. Notice the two different grade changes. So this is in a decreasing slope. Huh? Okay, negative going down. Okay, and then going down up to the lowest point. The lowest of the point of the curve can be found here, and then it will go up. Okay. If you remember, the property of the grade diagram is that the area under the grade diagram is the difference in elevation. So if you want the by the way, the stationing of PCC is the same with the stationing of the PVI. Okay, our point here is the elevation. If you want to get the elevation, we can get this vertical distance here. And that vertical distance is the area of this diagram here, the trapezoid. All right. The length of that is L1, that's 290. That area, I shaded it dark yellow. That area there, that area is this difference. So we can compute that. This is a trapezoid. That area is equal to 0.04 plus 0.0125 divided by 2 times 290, and that is 7.613. So that area is this height here, 7.613. So knowing that, then the elevation of PC is 110.2 minus 7.613. This is it. All right. So the answer is 102.587 meters. Okay. Did you get it? So we just use the fundamental here. I hope you got the properties of an unsymmetrical parabolic curve. So you know why is it so, what's the difference between that and the symmetrical parabolic curve. So if the tangents does not meet at L/2, that's unsymmetrical. So for symmetrical parabolic curve, it always meet at L/2. That is why this is now asymmetrical. Okay, so the tangents meet at halfway between their lengths. Another symmetrical curve halfway between their lengths. Okay. Now, by the way, there is a formula for this. If you can memorize the formula, but you need G3. No, sorry, L1 and L2. You need L1 and L2. There is the formula for this offset, vertical offset from the PCC to the PBI. Let's denote it with E. And this is the formula. So once you have computed L1 and L2, you can use this formula. L1 times L2 divided by 2 times L1 plus L2 times the change in grade. Just use the absolute value here. The change in grade, G2 minus G1. Let's try. So L1 is 290, L2 is 110, G1 is 0.06, and G2 and G1. Just use the absolute values. So it's negative here. So that is 3.988 meters, this vertical height. All right, so let's check. So we know the elevation of this. This is 98.6. So the elevation of PCC is 98.6 minus E. Minus E. Sorry, that should be minus. Excuse. All right. It's correct. Plus. 98.6 plus E, and that is 102.588, the same value here. There's a slight difference because of the rounding off. Okay, so that is the elevation of PCC. Or another way, but this will require G3, another way is to use the tangents. Okay, try to imagine how is it so. You can use the tangents. Okay, imagine here, 110.2. You go down by the vertical drop here, and you go down by the vertical drop of the screen from here, this point to that point. Look here, 110.2 minus 0.04 times L1 over 2, which is 145. Another minus 0.0125 times L1 over 2 also. This is L1 over 2. You will get the same result. So that's the vertical drop of this line and the vertical drop of this tangent. This is also L1 over 2. You can get the same answer. Okay? Okay. So by the way, I have a challenge question. Okay? So try to answer this and comment your answer in this below, no? In the video. Determine the grade and elevation of the curve at station 5 plus 800. So meaning 100 meters from PVC, BVC. Okay, the elevation and the grade. Okay, and also the stationing of the lowest point of the curve. Okay, so maybe that's very easy for you to solve. Just locate this point here. So what station is that? The lowest point of the curve. So just comment your answer below. Okay, so I hope you learned something about unsymmetrical parabolic curve. So there are two videos of this. The symmetrical, I suggest you watch that video, then this video here. Okay, so this is just using the fundamental formulas. Okay, the fundamental principles. So don't forget, again, don't forget to subscribe to our channel so that you can get updates of our recently uploaded videos. So please subscribe and watch our other videos. So write a comment if you learned something from the video. So thank you so much for watching.